Welcome to Module 7, Using Microphones. This module is divided into 3 submodules. First, we'll look at how to use single microphones and the issues associated with that. Then we'll look at multiple microphones, using more than one microphone to record a given sound source. And in Module 7c, we'll investigate techniques for recording voice. Understanding this learning module will enable you to avoid the 2 main sources of interference when using single microphones, demonstrate the 4 stereo microphone techniques, and explain the advantages and disadvantages of binaural miking. Let's go on to Module 7a, Single Microphone Techniques. But before we begin, what do you think is meant by the term working distance when it refers to microphones? What do you think will result if we use several mics at once, each mic recording a single source of sound, as in each one recording a separate instrument? Okay, let's begin Module 7a, Single Microphone Techniques. When we say single microphone techniques, we're referring to using one microphone to record a single source of sound. We may be using many microphones at the same time to record many instruments, as is often done in recording music. One mic for the vocalist, one mic for the kick drum, one mic for the snare, so on and so forth. Let's first start by considering how close we place the microphone to the source of the sound, or what we know as working distance. In the case of distance miking, the microphone is 3 or more feet away from the source of the sound, and it receives direct sound and reflected sound. 2 common uses of this would be in what we call accent miking, which is often used to accentuate a solo performance, and it's also very good to capture the sound of the environment, what we know as ambient miking. These would be distance miking techniques. If, on the other hand, we place our microphone in less than 3 feet, anywhere from 1 inch to 3 feet, we know that to be close miking, which is characterized by a tight, present sound, very much as if someone came closer to you as they were speaking. Close miking has 2 problems associated with it: mic interference, or leakage, and boundary interference. Again, those 2 sources of interference are multiple mic interference, or leakage, and boundary interference. Let's take a look at one source of interference, leakage. Leakage occurs when more than one microphone is used to capture the sound from more than one source. Oh, no, wait a minute, Mr. Rudisil, I thought you said this was single microphone techniques. Yes, it is single microphones, but it's single microphone for each instrument. So we may be recording more than one instrument. Each instrument has a single mic on it, but we have several microphones recording at the same time. As an example of microphone leakage, consider this sketch from David M. Hubbard's Microphone Manual. Here we see 2 performers, each with their own microphone. We see the sound traveling from the first performer into the first performer's microphone, but we also see that same sound leaking into performer number 2's microphone. And similarly, the sound from performer number 2 leaks into the microphone of performer number 1. This is leakage, and there's many ways to deal with it. Let's look at a few. Perhaps the most obvious way is to physically separate the 2 sound sources, put them each in a different room or a different cubicle where the sound won't leak. Well, this approach is possible, but it may not be feasible. Another approach is to place the microphones closer to their source. This results in the amount of leakage that actually gets into the microphone will be negligible. Another approach is to be sure to use directional mics and place them so that the sound from the other sources will be rejected because the mics are not sensitive in that direction. Another possibility that is often used in recording studios is to isolate the sound sources with what's known as a flat or a gobo, very similar to the first approach but much more practical. Another approach is to eliminate the microphones altogether and record directly from the instrument into the recording device. Now, this is only practical if the instrument you're using puts out an electric signal. It does not work for acoustic instruments. Finally, here's the technique you should be most familiar with. Abide by the 3-to-1 rule. Okay, well, what's the 3-to-1 rule? As an example of the 3-to-1 rule, in a situation where we are recording 2 tom-toms, using a separate mic for each tom. The 3-to-1 rule tells us that the distance between the two microphones must be 3 times greater than the distance between each microphone and its recording source, in this case, the drum head. Another example, in recording a choir, the distance between the two microphones must be at least 3 times the distance between each microphone and the center of the choir that is focused on. Let's take a look at the second source of interference, boundary interference. Again, from David Huber's microphone manual, here we see a speaker whose direct sound goes right into the microphone, but also her voice bounces off the floor and a reflection of her voice goes into the microphone, delayed by some time. In other words, her voice bounces off of a boundary. When both sources of sound are added together, some will be in phase and some will be out of phase, and the end result is what's known as comb filtering, a usually undesirable effect caused by reflected sound getting into the microphone. Well, one very elegant solution is to simply relocate the microphone to the boundary. Here, any reflections will be of such a short distance that any phase cancellations will be at a very high frequency beyond our range of human hearing. In the mid to late 1980s, some very clever engineers at the company called Crown International decided to use this effect to advantage, and they developed the boundary microphone, which is a microphone with its own boundary. According to the myth, they determined how far away from the boundary the microphone needed to be by using a simple credit card, which is about 1 or 2 millimeters of thickness. When compared to other microphones, it turns out the frequency response is a function of the surface area of the boundary on the microphone, and that the directional response, by nature, is hemispherical. That means half of a sphere. So imagining the response characteristics of an omnidirectional microphone being a sphere, the boundary of the boundary microphone blocks all the sound from one hemisphere. This shows the classic Crown boundary microphone. In summary, we are concerned with 2 sources of interference when using a single microphone technique. The first is leakage interference, and the second is boundary interference. The result of either of these is phase distortion. This completes Module 7A, Single Microphone Techniques. But before we continue, can you describe 2 forms of interference and the ways to deal with each? Can you describe the characteristics of close miking and distant miking? If so, please continue to Module 7B, Multiple Microphone Techniques.